Alright, so we're asked here to use an addition or subtraction formula to find the exact value of this function. We've got 5 pi over 12 plugged in. If we're not really digging the whole 5 pi over 12 because it's a radian, we can convert that. So have your calculators handy as we do this conversion. At 5 pi over 12, I want to convert that over to a degree measure. If I convert that over, now the pi's will cancel out. Basically got 5 times 180 all over 12. What's that come out to be? 900. That's a little large. What is it? 75. Okay. So this comes out to be 75, meaning my degree measure that we're plugging into sine here is 75 degrees. If we're going to use an addition or subtraction formula for sine, and we got a 75 that's plugged in, since it ends in 5, we know we could use 45 degrees as a special angle to help set this up further. And if we're going to use 45 degrees, trying to get back to 75 degrees, I would have to add on 30, which conveniently is another special angle. So you've got your sine of your A plus B. If you follow the formula for sine of A plus B, you would have the sine of A first, sine of 45 degrees, times the cosine of B second, cosine of 30, plus cosine of A, cosine of 45 degrees, times the sine of B, sine of 30. Using the formula, we expand out to that point, and now we go through and individually evaluate each part. To do that, you refer to your special right triangles. For sine of 45, cosine of 45, you look at the 45 right triangle, right? For sine, you're looking at opposite 45 over hypotenuse. That would be 1 over root 2. And as long as we're on the 45-degree triangle theme, over here, the cosine of 45 also would be 1 over root 2. Now for the cosine of 30, sine of 30, you got to use the 30-60 right triangle. So for a 30-60 right triangle, if we're talking cosine, the side that is adjacent to the 30-degree angle is going to be what? Root 3. So root 3 over the hypotenuse, which would be 2. And then for sine of 30, you're taking the side that's opposite 30, which would be 1, over hypotenuse, which is still 2. You clean this up a little bit. First set of fractions, multiply through the numerator. 1 times root 3, you get root 3. Denominator has to be 2 root 2. Plus second set of fractions, multiply through. In the numerator, you'd have 1. Denominator ends up being the same. Make this a little more official. We put this together as one fraction. So 2 root 2 is my denominator. Got root 3 plus 1 in the numerator. There's my exact value for the sine of 75 degrees, which originally was the sine of 5 pi over 12. All right, so same strategy here. Got to use addition or subtraction formulas to find the exact value of the cosine of 105. Since it's 105, trying to split this up into 2 special angles. Ends in 5, so I'm rewriting this as 45 degrees again, plus or minus something. In this case, it'd have to be plus since we're going to 105, and that plus would be 60. Hey, what do you know? It's another special angle measure. So as you look at your formulas, you've got the cosine of A plus B. Following that form, we would take the cosine of A first, cosine of 45 degrees, times the cosine of B, cosine of 60. Then subtract the sine of A, sine of 45 degrees, times the sine of 60. So that's the sine of b. So addition formula for cosine leads you to that expansion, and now we've got the same kind of situation as we did before. Go through, evaluate each piece. We start with the 45-degree stuff, using the 45 right triangle, cosine of 45, sine of 45. Each will be 1 over root 2. For this cosine of 60, we're talking about a side measure that's adjacent to 60. That would be 1. Hypotenuse would be 2 in that 30-60 right triangle. Times over here, we got sine of 60, so opposite 60 would be root 3. Hypotenuse again on that triangle is 2. Got all your values that you need. Start multiplying through. If you consider what we just did on the previous problem, we know eventually this is going to go together as one fraction, so we could kind of cut to the chase. Common denominators will be the 2 root 2 stuff. The numerator will be the resulting numerators that we get when we multiply each of these fractions. So here we've got 1 times 1, 1, minus, for the second set of fractions, we got 1 times root 3, so root 3. There's your exact value for the cosine of 105. If we're doing the cosine of pi over 12, you can leave it as a radian measure. If we want to do the conversion like we did earlier, that'd be fine. Doing the conversion, pi over 12, multiplied by 180 over pi. Pi's would cancel, leaving you with 180 divided by 12. If you divide that out, 180 divided by 12 is how much? 15. Here we're trying to find the cosine of 15 degrees. Once again, ends in 5. So as I set up the addition or subtraction, I'd have 45 degrees in here. And this time we're subtracting. Yep, subtract 30 degrees to get back to that 15. So here's your A, here's your B. Following the formula for cosine and the subtraction idea, it'd be the cosine of A, cosine of 45 degrees, times the cosine of B, cosine of 30, plus the sine of A, sine of 45, times the sine of 30. All right, I feel like I've seen this before. If you go through and evaluate each piece, 45s, we've got 1 over root 2. Transfer down. And these 30s, we got to look at the 30-60 right triangle again. Cosine adjacent to 30 is going to be root 3. Hypotenuse 2. Sine of 30, opposite 30 is 1. Hypotenuse 2. And once again, we end up with a fraction over 2 root 2. We're in the numerator. This first product, we've got 1 times root 3. The second product, we've got 1 times 1. There's your exact value for the cosine of pi over 12. All right, definitely need the formula sheets for this one, since we don't often have to break up stuff in terms of tangent. How we start, though, is the same as before. It's the tangent of 105 degrees. Ends in 5, so 45 is useful. Got to add on 60 to get to 105. Here we've got a tangent of A plus B. Using that formula now, how does that formula set up? It's a fraction, isn't it? In the numerator, you've got what? The tangent of A? Tangent of 45. And what else? Okay, plus tangent of B, yeah. What about the denominator? What's that start with? Should be 1, right? 1 minus the tangent of A times the tangent of B. Tangent of 45. Tangent of 60. So at least this one gives us something slightly more interesting to work with. We got some tangent values we need to find. What's nice is when you find the 2 on top, you've got those same 2 on the bottom, so you can just fill them in. If you're going to find the tangent of 45 degrees, you look at a 45 right triangle. Opposite 45 is 1, right? Adjacent is 1. So the tangent of 45 is 1 over 1, which is 1. Plus tangent of 60. Opposite 60 is root 3. Adjacent is 1. So root 3 over 1, get root 3. Like I said, once you get those values for the top, got the same kind of stuff on the bottom, so it's going to be 1 minus tangent of 45 again, which is 1, times tangent of 60, which is root 3. This part right here you could just multiply out, and if you multiply that out, you've got 1 plus root 3 over 1 minus root 3. As exact values go and acceptable answers, that would work. All right, deciphering the information, considering what you got to find. We see all these 2x's, we know the double angle formulas will come into play. If we're going to use double angle formulas, you need to know 2 things. You need to know what the sine of x is, which we have, and you need to know what the cosine of x is. To determine the cosine of x, we set up a right triangle based on the given information from the sine of x. Since that's in terms of x, we let our angle measure be x. Sine of x is given as 8/17, so opposite x is 8. Hypotenuse is 17. Yep, we need to find the adjacent side here, so if you have to, you do a squared plus 8 squared equals 17 squared and solve for a. But if you recognize the triple, we've got a Pythagorean triple of 8, 15, and 17. So the cosine of x, adjacent over hypotenuse, based on this triangle, we've got 15 over 17. But wait, we haven't deciphered this information yet. It's kind of unique how it's presented based on what we're used to, but if x is going to fall between 90 degrees and 180 degrees, what quadrant are we in? Second quadrant. So if we're in quadrant 2 and we just found the cosine value, what must that value be? Must be negative. And here's the thing about finding sine of x and cosine of x first. Once you've determined what those are, and you've determined the signs on those values, you don't have to worry about adjusting your signs in any answers from here on out. Okay, you just plug in. If you plug in, you'll have the right answer, assuming your signs are correct that you're plugging in. So let's go to the plug-in portion. Let's start with the sine of 2x. The sine of 2x, that formula is 2 sine of x, cosine of x. Trying to find the sine of 2x, I must plug in sine of x and cosine of x and multiply to 2. So if I set this up, it's 2 times the sine of x being 8/17 times the cosine of x, which is negative 15 over 17. I put this 2 over 1 and I multiply everything through. I'm multiplying 2 times 8 times negative 15 on top, multiplying 1 times 17 times 17 on the bottom. What does the numerator become? Numerator? Was it 240? Negative 240. Denominator would be 289. So there's your sine of 2x. We're also asked to find the cosine of 2x. So you look at your formula sheet, in this case your notes. You've got three options for the cosine of 2x that you can use. You pick one, any one that you like, because any one will work. But if you base it off of what was given in the first place, being sine of x, which of the cosine of 2x formulas do you have that only has the sine of x in it? Okay. 1 minus 2 times the sine squared of x. So you see this sine squared of x, that means sine of x, whatever it is, squared. So if I plug in, it's 1 minus 2 sine of x was 8/17. We're squaring that guy. As we square all this out, you've got 1 minus 2 times 8 squared, 64, 17 squared, 289. Got to follow your order of operations. This 2 is over 1, so we got to multiply that to the 64 over 289. I'll bring that up here a little ways. Now let's see here. We've got 1 minus 2 times 64 be 128, right, over 289. That 1 is basically 289 over 289. So what's 289 minus 128? 161. We've got 161 over 289. So there's cosine of 2x. Since we've done all that dirty work, that makes finding the tangent of 2x not such a big deal. So let me squeeze that guy in up here. Tangent of 2x. We now know that the tangent of 2x is sine of 2x over cosine of 2x. So here's my sine of 2x answer, my cosine of 2x answer. If I put one over the other, the 289s cancel out, and you're left with the negative 240 over the 161.